Welcome back to My Smart Learning. We're doing another physics lesson today on kinetic energy. Last time we looked at gravitational field strength, the gravitational potential energy, and we've looked at work done. This is for GCSE Science and Physics for my Year 9s who are missing their lessons this week. However, it's useful for pushing Year 7s on, so we can push you to get a higher grade. But you also need it for Year 9, Year 10, Year 11, because it's towards the GCSE exams at the end of Year 11. So, kinetic energy. But before I start my lessons, I know you all moan about my dead jokes, as you keep calling them, the dad jokes, dead dad jokes. So to show you that you guys don't know what you're missing and you don't know what you're getting in lessons, let's compare my jokes to Alexa. See what Alexa's joke is for today. Alexa, tell us a joke.
How do you know you're in love with a robot? You feel a little spark.
There you go, you see. Science joke, and you're moaning about my jokes? Stop it. Anyway, so kinetic energy, a learning objective. What is kinetic energy? Kinetic energy is that's a learning objective. What is it? And what does it depend on? And how do I calculate it? But like I do my little starter activity, the recall quiz, the recall PT, the progress testing, I like to call it the high five. You get all 5 right, you get a virtual high five from me. So, question 1, what is the unit of energy? Question 2, there's 2 types of energy. Question 3, what is the law of the conservation of energy? These are very similar to the ones we've done before. Work done equals, so what is the formula for work done? And the last question is from our previous lesson, GPE equals, right, you should know this one. Right, press pause, make sure you've written them all out, and we're going to check the answers now. So the unit of energy is a joule, capital J-O-U-L-E-S, joules. The 2 types of energy, is energy stores and energy transfers. Energy stores and energy transfers. The conservation of energy, question 3. The conservation of energy is energy cannot be created, it can't be destroyed, it keeps changing from one form to another. Number 4, work done is force times distance moved. Force times the distance moved. And GPE equals mgh. GPE equals mgh. Mass times gravitational field strength times the height. So what we're focusing on today though is kinetic energy. Kinetic energy is, or the energy stored is in an object is due to its motion. But what 2 things does it depend on? So it's the energy in a moving object. So if the car is moving, it's got a kinetic energy store. If a ball is flying through the air, it's got a kinetic energy store. But how much kinetic energy does it have? What 2 things does it depend on? Any ideas? Well, it's to do with the mass of the object and the speed of that object. So the heavier it is, the more mass there is, the more kinetic energy it will have. And the object's speed, how fast it's going, that will depend on the amount of kinetic energy it has. So here is a question. Here's a big truck and here is a bog standard car. If a car and a lorry are both travelling at the same speed, the lorry will do much more damage if it hits something than the car. Why? So if these 2 travelling exactly the same speed, which would you want to be hit by? Obviously you don't want to be hit by any of them, that's just bad. But if you were to be hit by one, which one will cause you more damage and why? Well, it sounds obvious. You don't want to be squished by any of them, but the lorry would be a lot worse. Why? They travel at the same speed, but the lorry will have a lot more kinetic energy. So it will hit you with a lot more impact force as well because it's got more mass. So the lorry has more kinetic energy even though they're both traveling at the same speed because it's got more mass. Now if something is traveling much faster, obviously it can have a lot more kinetic energy. Now get this down. This is the equation that you have to memorize for this lesson. Remember, we've learned one from 2 lessons back. W equals Fs. Work done is force times distance moved, but we have the letter S for distance. And we learned GPE equals mgh. Here's the third one that you need to memorize. You have to commit this to memory. So get this down and keep going over and over and over again. Make it into some kind of rhythm, some kind of pattern, some kind of weird thing, just so it sticks in your head. Okay. Kinetic energy is half, which is 0.5, times the mass, times the speed of an object, squared. What do I mean by squared? Well, I multiply this by itself. So if this number was, I don't know, 3, then you do 3 times 3, which would be 9. So 3 squared would be 9. If it was 5, it would be 5 times 5, which would be 25. So that's your formula. What are the units then? The kinetic energy is a form of energy, so it's measured in joules. Mass has to be converted into kilograms because it's mass. The speed is measured in meters per second. So how fast are you traveling? How many meters have you covered per second? Meters per second. Now you'll see on the next slide that I'm going to convert this speed and I'm going to use the letter V instead. So how are you going to memorize this? Write this out in big, make it colourful. You're going to have to learn this. Ke equals half mv squared. Half mv squared. The mass, what's the V? Well, speed, but V is a better letter to use because V stands for velocity. Now what is velocity? Velocity is just the scientific word for speed. It's how far something is travelling. So V is the velocity squared. The difference is that speed is what we call a scalar quantity and V is what we call a vector quantity. So speed just has how fast it's going but doesn't tell me which way it's going, whereas V is the speed, how fast it's going, but it's also telling me the direction. A scalar is just magnitude. It just has a number, but a vector quantity has a number, but a size, a magnitude, but it's also got a direction. So for instance, a car is traveling at 20 meters per second. That will be its speed. But if I said a car is traveling at 20 meters per second west, then that would be its vector quantity. Okay, so it's a velocity. So Ke equals half mv squared. 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 GPE equals mgh. That's right. Ke equals half mv squared. You got to memorize it. I sound stupid. I look like a wally doing it, but if you do, it's going to be harder to memorize if you just try and rote fashion learn them. Try and make them into some kind of rhythm, some kind of pattern, and you're going to memorize them. Okay, because you need to use that, and you're going to put this. You can put this into a form of a triangle. So kinetic energy is any object that moves will have kinetic energy store. The amount of kinetic energy store an object has can be found using this formula. Ke equals half mv squared. Half times mass times velocity squared. Kinetic energy in joules, mass in kilograms, velocity is meters per second. Ke equals half mv squared. Ke equals half mv squared. So let's look at some example questions. No, this is not my car. I wish it was, but it's not, unfortunately. A car with a mass of 500 kilograms is moving at a speed or a velocity of 12 meters per second. How much kinetic energy does it have? How much energy does it have? Well, we have to use our formula. Ke equals half mv squared. So half will be 0.5. The mass is 500 times the velocity squared. So there's my velocity, 12. It'll be 12 times 12. So if I put that into my calculator, half times the mass, which is 500, times the velocity squared, which is 12 times 12, which is 144. Stick that into your calculator, you'll get 36,000. That should be a capital, not a little one, capital J for joules. Or it could be 36 kilojoules. So that was an example question. Have a go at these questions here and pause the video and see how you get on. So spend about 5-10 minutes or so. You don't need to obviously write all the question out, but it might be useful. But you must make sure whenever you're doing any scientific calculations that you must write out the formula, then substitute the numbers in on the next line, then do the calculation. You might need to rearrange it, and then always remember to put your units down. So if it's kinetic energy, it will be in joules, but if it was the mass you're trying to calculate, it will be in kilograms, and if it's the velocity you try to calculate, it will be in meters per second. Now some of them will get a bit tricky, because if you're trying to calculate, for instance, if you're trying to calculate, we'll come back to this equation here, you'd have to do the opposites. Now this, go on to the very, very high grade questions when you go into grade 6, 7, 8, 9, you might need to rearrange this equation. So for instance, you can have, if you time something by half, it could be the same as saying divide by 2, because if you time something by half, it's the same as saying divide by 2. So if I wanted to work out, let's say, the mass, if that was divided by 2, I'd move the 2 up to here. So it would be 2ke equals mv squared. So if I wanted to work out the mass, it would be 2ke divided by, because I moved that under there, velocity squared. Okay, it's a bit tricky. Then you plug in your numbers and you get the mass. However, the trickiest one that most people find difficult is if they're trying to work out the velocity. Because you got velocity squared, you have to do the inverse of squared, which is square root. So if I'd wanted to make that into divide by 2 again, I'd go times that by 2 there. So 2ke is mv squared. And if I wanted the v, I'd make the mass go under there. So it'd be 2ke divided by the mass, but that'll be v squared. So 2ke over mass is v squared. To make out the v, I'd have to do the opposite of squared, which would be square root. So it would be the square root of 2ke over the mass to calculate the velocity. So a little bit tricky, but we'll have a go. So here's some questions. Press pause, have a go at those questions, and we'll go through them now. So, calculators are ready. Make sure you got your calculator. Calculate the kinetic energy if a car travelling at 20 meters per second has a mass of 1,200 kilograms. So, Ke equals half mv squared. So half. So 0.5 times the mass, which is 1,200, times, now what I'm going to do is I'm going to put that into a bracket because it's v squared. So I'm going to times it by open bracket. I got 20, you can either press the squared button or just times it by itself again, which I'm doing here, 20 times 20. Close the bracket, and the answer is, for this question, 240000. So that's 240,000 joules. 240,000 joules, or 240 kilojoules. So all you did was you did mass times velocity squared, and then you have to half it. So 0.5 times 1,200 times 20 squared. Question 2. A dog running across a field at a speed of 1.2 meters per second. Pretty slow dog if it's running at that speed, but anyhow, it's probably one of those big fat dogs, can't move anyway. Anyway, 1.2 meters per second, that's probably about your walking pace. So with a mass of 3.2. So you want to work out the kinetic energy. So calculate the kinetic energy. Ke equals half mv squared. So you have to write that out first. And then my half, 0.5 times, so my mass is 3.2. So 0.5 times 3.2. Then times, I'm going to open the bracket. You don't have to, but I'm going to open the bracket. 1.2 squared. Or just do 1.2 times 1.2. Close bracket, and that gives me the answer of 2.304. So I'll keep it as 2.30 to keep it as 2 decimal places, or because the question's only got 1 decimal place, I'll just keep it as 1 decimal place. 2.3 joules. 2.3 joules. And question 3. Now this one's a bit trickier. Ke equals half mv squared, but it says think about the units. I got my velocity, I need to do 46 times 46. I got my half, my mass, it's 58 grams, not kilograms. So I need to convert this into kilograms because mass has to be in kilograms. So it'll be 58 divided by 1,000 equals 0.058. So that's my mass. So I'm going to times that by half, 0.5. So 0.5 times 0.058 times by, I'm going to open up a bracket, 46 squared, close the bracket, and I've got an answer of 61.364, and yeah, so I can keep it as 61.36 or 61.4. Try to keep it to 2 decimal places. Look at what the question's saying. If the question's giving you information as 1 decimal place, you can keep it as 1 decimal place. So 61.4 or 61.36. But always write out what the full answer says on your calculator and then round it. Just read the question carefully though, because the question might tell you to give it as 2 significant figures. So if this was in 2 significant figures, the answer would just actually be 61. 61 joules. Okay, let's have a go at a few more. Here's some more questions. Press pause, have a go at them. They're going to get a lot trickier as you get down towards the bottom because they're going to the higher grade questions. The previous slide was up to sort of grade 4, maybe 5 max questions. This one will go up to your grade 6 and maybe 7 questions. So press pause, have a go at those, and we'll work through them now. So Ellie drives her car at a speed of 30 meters per second. If the combined mass of her and the car is 1,000 kilograms, what is the kinetic energy? Similar to the previous questions then, Ke equals half mv squared. So 0.5, which is my half, times my mass, which is 1,000, times my velocity squared, 30 times 30 is 900, but I'm just going to put it all in, open my bracket, 30 squared, close the bracket, equals, gives me 450,000. So it's 45 with 4 zeros. 450000. So 450,000, so that's 450 kilojoules. Okay. Question 2. Samantha rides her bike at a speed of 10 meters per second. If the combined mass of Samantha and her bike is 80 kilograms, what is her kinetic energy? Well, Ke equals half mv squared. Ke equals half mv squared. So Ke, so I've got my 0.5, which is my half, times my mass, which is 80, times by, I'm going to open my bracket, velocity squared, 10 times 10, which is 100 obviously. I'm going to close my bracket, and that gives me an answer of 4,000. So that's 4,000 joules of kinetic energy store. Question 3 and 4 are going to be the hard ones because I'm not calculating kinetic energy now. It's that what I was talking about in the previous equation where you have to rearrange it. So Ethan is running and has a kinetic energy of 750 joules. If his mass is 60 kilograms, how fast is he running? This is the tricky one where you're trying to work out the velocity. So you have to square root it, remember? So I said we got Ke equals half mv squared. Now if you times something by half, it's the same as saying divided by 2. I move the 2 to the top, so it's 2 Ke. So it's 2 Ke, so it's 2 times that. And I've got v squared left. So to get the v squared, so I need to, so I've got my mass left on this side, I need my mass to go onto that side. So it'll be 2 Ke divided by 60, divided by the mass, and then I need to square root the answer. So if I want to do it all in one go, I'd have to press the square root button, I'd have to open the bracket, so this is complicated with your calculator. I said 2 Ke, so it's 2 times 750. I'm going to close my bracket, so far I've got square root, open bracket, 2 times 750, close the bracket, and then I'm going to divide it by my mass. So divide it by the mass, which is 60, and then I'm going to press equals. And that gives me an answer of 5. So how fast is he running? Sounds about right. 5 meters per second. That's a pretty fair sprint. Okay, not Usain Bolt style sprint, because that'll be like 10 meters per second. That's fast. But an average Joe or an average Ethan, 5 meters per second is about right. So that equation, that is a more of a grade, probably 6 plus, maybe a 7 question. Okay. Question 4. Ruben is walking to town. If he has a kinetic energy of 150 joules and he's walking at a pace of 2 meters per second, what is his mass? So this is that other equation, the same equation, Ke equals half mv squared. Ke equals half mv squared, but it's the mass I want. So remember, if you've got 0.5 times mass times velocity squared, times something by half is the same as saying divided by 2. So I'm going to move the 2 to the top. So 2 times kinetic energy. So 2 times 150. That'll be at the top of my equation. And then, because I've got the 2 Ke at the top, and then I'm going to move my v squared to the bottom. And that leaves me with the mass. So I'm going to divide it by v squared. Well, what's the v squared? It's 2. So it's 2 times 2. So I'm going to do 2 KE. So if I was to do this in my calculator, I'll do an open bracket, 2 times 150. Oh, go back. 2 times 150, close bracket, and then divided by V squared, which is 2 times 2. So you have to open bracket again, 2 squared, close bracket. So and you get an answer of 75. So 75 kilograms. So that sounds about right. So Ruben is walking to town. If he's got kinetic energy of 150 joules and he's walking at a pace of 2 meters per second, what is his mass? To work out the mass, I'd have to go 2 KE divided by V squared. So it'll be 300, because 2 times 150 is 300. 300 divided by 2 times 2, which is 4. So it's 300 divided by 4, which gives you 75 kilograms. So that's how you do that. So those 2 questions, that's probably a grade 6 question. That's probably more of a 6 plus, maybe going into 7 grade question. You could just do it by substituting, but you do have to rearrange it. Alright, and that's where it gets a little bit trickier. The first ones will be up to maximum grade 5 because you're just substituting the numbers into the questions. But the main thing is, what is KE? KE is the kinetic energy. It's based on how much something's moving. What's it based on? The 2 things. We'll come back to that in a second. Here's some more questions. See if you can have a go at describing what happens to the GPE and the kinetic energy. So it's putting those 2 lessons together, the kinetic energy and the gravitational potential energy. Remember the interchange, like that pendulum that we did on that first couple of lessons. Okay, so you can have a go at those questions. You need to write these stories, energy transfer stories, because it's transferring from one store to another store. But to finish off then, are you confident with this then? So how confident are you? Can you identify what KE depends on? What is KE and what does it depend on? And can you calculate KE? And then can you make it even more difficult? Can you calculate the mass? And can you calculate the velocity? Remember, the KE is the amount of movement energy something has stored in it. How you calculate it is half mv squared. Are you confident? Are you okay? If you're not so, get back to me on Show My Homework. You can leave me messages on Show My Homework or on the YouTube channel. If that's been useful and you've learned something today and you're getting stuff out of this, please watch the videos, like the videos, share the videos and subscribe to the videos. Hope to see you next time. Take care. Bye.